All right. Thank you so much for starting the recording, Mark. Hey, everybody at home. My name is David Justice. It's very nice to see everybody's smiling faces today. You are here at the Hyperlight Fortnightly community meeting. Hyperlight and this project is a CNCF sandbox project, and we follow the CNCF Code of Conduct, which in short means please be kind to each other, treat each other with respect, and please raise your hand. You will be recognized. If you have agenda items, please add them to the agenda link within I guess, the agenda link that's available on Slack in the Hyperlight channel and other places. Um, without further ado, I don't know. Do we have any agenda items today? Don't believe we do.
Yeah,
Has
I
anybody
added
added
some
anything?
I added some tentative ones.
Oh, fantastic.
I'm not sure if there's things we
Us.
want to talk about, but perhaps. So it could be a good starting point for a discussion.
We also have an
Excellent.
announcement
Ooh, good, good,
listed on
good.
that.
All right. So if you are attending, please consider adding your attendee names to the attendees list in the notes. And James, thank you so much for taking notes for us today. I appreciate you. So without further ado, let's get into the announcements. I'm not sure who placed this announcement there, but whoever did, please feel free to take the floor.
So that was also me. I don't really remember if we announced this last time, but 061 I think happened 2 weeks ago, which I think might have been after our community meeting. Um, but overall, yeah. Anyway, we released 061. It's a patch release. I think one of the main things to highlight from that release. Um, from my end, I think we brought back the OS function definitions regions, which is something that we needed for introspection in the Hyperlight WASM support for modules. I see here also, Simon, you added support for the Hyperlight host to build to a muzzle target. I don't know if you want to comment anything there. But yeah, small release. Just figured it would be good to announce.
Thank you for the context, Dan. Simon, I see you had a hand raised. Uh,
That was just because I added a discussion item. It's not quite a demo. I got some data to share about snapshotting.
Ooh, cool, cool, cool. Exciting. Uh, Excellent. Let's see. Any other announcements? I don't see other announcements there. However, I do see discussion items. In the future, if folks have discussion items, as you put down a discussion item, please put like initials next to it or something like that to indicate where it's derived from. Um, Jorge, I saw your hand was up for a moment. Did you want to?
Yeah, it's not really my announcement, but there's now benchmark dashboard for Hyperlight and in particular Hyperlight WASM. Ludwig, do you have the link handy?
I do, but I do think you need to be a member of the org to see it. Maybe it's not public yet. I'm not sure yet.
Oh, fair enough.
Let me see if I can open it in the incognito tab. Oh no, you need to log into GitHub to see it. So I'll get that fixed up. But yeah, it's supposed to be a dashboard that anybody can see that compares some performance between different runtimes. Well, yeah, I'll drop a link here.
I just pasted the link on DMD.
All right. I'm okay. So for everybody that can see the link, and I'm sure it'll be added to the notes, is there anything that you want to bring up about the link and the data that is shown there? Like anything notable, anything that jumps out at you?
Hmm. Well, there's a couple of things. The first thing is that Hyperlight WASM is pretty slow. Um, and the second thing is that it uses quite a lot of memory. So that's the two things that stand out to me.
I can't raise my hand because I'm doing the recording, but do we want to maybe share it to show what it would look like?
Sure, I could share it. Let's see. Okay. Can you see this?
Yes.
All right. So it's currently showing three different testing strategies. I have the reuse strategy, reload, and new strategy. And the difference is with the reuse strategy, we reuse as much of the sandbox we can um, for the maximal performance. Uh, for the new strategy, for each incoming request, we create a brand new runtime every time. So obviously this is slower, and this reload is something in between. Maybe I should start to mention that this is a throughput test. So we have a HTTP server that uses Hyperlight in different runtimes, and we test how many requests it can handle per unit time using like a load, sending a load to it. Simon, did you have a question?
Yeah, I did. When you say Hyperlight WASM, is it using components or modules?
This is a component.
Okay. Might be interesting to see modules as well, if that's if that's possible. I don't know no concept of what's being executed.
Yeah,
I imagine it's something trivial.
yeah. Usually it just goes into the runtime, does something trivial like returning or it's supposed to like redirect the URL of a request, but it's a little bit artificial right now. If you hover over it like this, you can also see how many requests they handle. Jorge.
Yeah, so the purple line is wasn't time and the orange is wasn't time AOT.
Yeah.
I find it odd that I would have expected that to be the other way around. Like wasn't time without AOT can handle is faster than with AOT.
You're right. So yeah, it looks like wasn't time without AOT is faster. Haven't had too much look into these numbers to figure out
That's
why.
fine. Yes. Yeah.
But yeah, interesting observation.
And also, if you scroll further down in peak memory usage,
Mm-hmm.
do you know if something changed in the way we measure memory? Because
Oh yeah,
that seems to be a big jump.
yeah. So here, so because Hyperlight WASM used too much memory, uh, it's basically I wasn't able to run it on our runners because just the process crashed. But here I actually was able to bump it up again. So here I'm just using the same settings as all the other runtimes, which was as like a default thread pool size of 4. But over here it was just a single runtime we had. So yeah,
Oh, okay.
it just
Okay.
I used 4 more Hyperlight instances here. Yeah. And here's the new strategy. So yeah, for each request, create a new sandbox. And obviously this is pretty slow. And the WASM time, for example, has 1 request per second, which makes sense because it's, compiling and stuff like that. So it's not very useful for the WASM instance, but yeah, good to see anyway. Uh, Hyperlight dummy is just it uses Hyperlight core with a very simple guest with just one guest function that does almost nothing, just to see what the baseline performance is for Hyperlight.
Yeah, I love seeing that performance is rather good. We are very good at creating sandboxes or well, VMs. We just need to get better at running wasm time inside of it.
Yeah, it looks like it. Yeah, I'll probably add our micro benchmarks to this page too, I'm thinking, because that could be interesting as well. But yeah, this test is more for checking how parallel we can run and how many HTTP requests we can handle. Simon?
Yeah, some of the data I have may inform some of this, but we can come on to that in a minute for them.
Yeah, all right, that's all I had. So I'll stop sharing.
Ludwig, this is fantastic. Thank you so much for sharing this. It's really great to see us get this kind of dashboarding, these kind of benchmarks, so we can start to see, what are changes and how they affect this performance. So, loving it and love seeing all the support from other folks in the project. So, thanks, y'all. Let's see. How do we feel about getting into your discussion items? Yeah. All right. I see consensus. So our first discussion item today is Hyperlight WASM release updates. Again, I'm not sure who put that in there, but whoever did, please, you have the floor.
It was also me just adding things in there because we didn't have any items. I figured, things that we might want to talk about. I don't have anything particular to discuss, but I don't know, Jorge, you've been working a lot on it. I don't know if not to put you on the spot, but
No, that's fine. I can comment on the release updates for Hyperlight WASM. So yeah, we are working. There are some challenges to releasing Hyperlight WASM in crates.io because of the way during the build process we build another crate, which is the one for the guest for the WASM time runtime. Crates.io doesn't like bundling crates together, so the idea would be that you have to publish it as a dependency, but it's not really an actual dependency for us. It's more like an artifact dependency. And there's an RFC to adding artifact dependencies to crates.io, but it's an RFC. It's not. There's a lot of open questions about it. So the solution well, I have an open PR to work around this, and the solution would be to create a tar that contains the crate that we want, and we untar it during the build process. It's not the cleanest solution, so maybe at some point we can come up with something nicer, especially if we can avoid having to compile and call cargo recursively inside of the build script. But until we figure out a different way of doing it, that's going to do the job. So the PR is open. The problem we're having now is that the runners are running out of disk space. But yeah, seems to be working. And then once that PR is merged, let me see the PR number. Yeah, it's a PR 78. So I'm going to paste it here in the chat. Once that's resolved, I have to fix the CI workflow for publishing, because we're going to have to do an extra 2 extra steps before publishing, which is creating the tar file from the other files in the repo, and the other one is committing those changes into the release branch. But yeah, we're going to get there. I think that by the end of the week, we should get ideally something published. Yeah, James.
Awesome. Work figuring out how to handle that. I just was going to add, in the side of this, we also updated the WASM time version and added an example so that we have some validation of the component model examples, and so both of those went in as part of getting closer to getting a release out.
And I'll take a look at getting the runner, the disk sizes increased too, so we don't run into that.
Yeah, I added some cleanup of unused files on before running the test, and that moved things a bit further, made things succeed a bit more. But now I'm hitting an out of disk space in the next step in CI.
Yeah, there's two options to fix it, I think. One is to, in our runners, we can specify like an optional data disk and then mount that somewhere. But then we'd have to configure it. I think the better way that might take a tiny bit longer is to update the Packer jobs to use a bigger image, and then when it gets captured, even if there's dead space in there, when VMs get created, it'll use it. So I'll probably try and do that. It just shouldn't take that long. We just need to republish the images.
Yeah, one of the reasons why we are hitting out of this space now and not before is because before we were building the wasm-time runtime in the repository tree, and now it's part of the build target in Cargo. And every time something small changes, Cargo appends a hash and makes a new build. And the build of wasm-time takes a bit of space.
Do we have any other questions on this? Okay. Let's see. Anything in the chat? I think we're good. Okay. What's our? Oops, I lost the agenda. I'm sorry.
Thanks, Simon is the next item.
Thank
Performance changes from snapshotting.
Okay, let me try and figure out how to share this with you. Hang on one second. This is a bit of a busy screen, but bear with me. Let me know when you can see.
I
can see a lot.
Okay. So, two console windows, lots of data on them. The left-hand side is running some benchmarks where we're using dirty page tracking for snapshotting data. So when we take a snapshot in order to revert to a previous state, we're doing that by tracking what pages have been altered and then only copying data for those pages. On the right-hand side, so here, all the snapshots are done basically by copying the entire memory that's allocated to, that's mapped into the VM each time we want to create a snapshot. There's three sets of benchmarks here. I'll describe what they are in a second. But the one thing to bear in mind is that whenever we do a function call in these benchmarks, post the function call, we're resetting the state of the sandbox back to what it was before the function call started. So effectively you could share the sandbox between tenants if that made sense in this mode. Okay, so the first group of benchmarks, so down to here, if you can see my mouse pointer on the right-hand side and down to here on the left-hand side. Remember that the left-hand side is the new behavior and the right-hand side is the old behavior. So all this does is measures how long it takes to make a function call, which resets state when the sandbox is of a specific size. And in particular, it's done by allocating a heap of growing size. So there's defaults where no configuration is provided. There's a 50 megabyte heap, 100 megabytes, 250 megabytes, 500 megabytes, 995 megabytes. And I suppose the thing to notice here is that the time taken to make the function call doesn't increase by a massive amount as you increase this size, right? So it's going from 107 microseconds in this example to 152. If we look on the right-hand side, the old behavior, the first thing to notice is that this number here, even though these things are not terribly accurate in terms of there's some fluctuation in them when you run the benchmarks, they're, for the purposes of what we're doing here, they're good enough to compare. So the first thing to notice is here where we're copying the entire memory, it's faster than here where we're tracking dirty pages. However, very quickly, this becomes much faster than this. So 116 microseconds versus 2 milliseconds. And as we go down and we get to this, basically a gigabyte sandbox, it's 45.8 milliseconds versus 152 microseconds. So clearly in that scenario, tracking dirty pages is better, but we'll come back to the difference between the top two in a minute. The second set of tests are just how long it takes to create a sandbox of those size. So over here on the new dirty page tracker, you can see the default sandbox takes 2.4 milliseconds, which is slow. There's obviously some other things we're doing that make this slow, but as we get to this gigabyte sandbox, it only takes 12 milliseconds. And again, this is because when we take a snapshot of this thing, when it's been initialized, so this is creating a sandbox that's been initialized to a multi-use sandbox. I probably should have said that. We're only tracking dirty pages. Whereas over here, you can see that, again, the initial one is faster, but then as we go down, it very quickly becomes a lot slower. So here we're 3 point something milliseconds, and here we're 58. And when we get down to, where is it, the 995, we're at 1 second, versus over here at 12 milliseconds. So again, a massive difference. The last set, so starting from here down to here, starting from here down to here, this is measuring, again, with a reset of state at the end of the function call. It's measuring a function call where we're passing two parameters of a particular size. So this one has two parameters of 5 megabytes, two parameters of 10 megabytes, 20, 40, and 60. Same over here. 5, 10, 20, 40, 60. And the thing to notice here is that this side is much faster with 5 megabytes than this side. And as you go down, then the balance starts to shift. And when you get to the end, well, this one's slightly quicker than this one. So there's some tipping point where things get faster to do dirty page tracking versus entire memory snapshot. Now, the question is, why does that happen? Well, another thing that happens when we have these large parameters is that we need to create a massive heap in order to support these parameters. In fact, on this 5 megabyte one, there's basically 160 megabytes of heap needed to support passing that 5 megabyte parameter, which is crazy, right? I mean, it's absolutely nuts. It's doing so many allocations. Now, what's happening is that because when it's obviously writing to those heaps, and because it's writing to those heaps, it's making the pages dirty, and therefore the dirty page tracker has a high percentage of the memory that the sandbox is using is dirtied, and therefore it becomes faster to copy the entire memory than it does to copy the dirty pages. So somewhere there is a heuristic, I think, where we can say if the percentage of pages that are dirty exceeds some number, then we should take an entire snapshot versus we shouldn't. I don't know where that is. I haven't even thought about how we might try and find it. I mean, literally, I created this about an hour ago. So that's the data I have. I haven't done any optimization on this. It's only working on, well, it might work on Hyper-V on Linux. I haven't tried it yet. It works on KVM. I feel like even though there's this degradation with large parameters, it's probably worth pursuing this and merging it, and then thinking about how we put in place a strategy to do both dirty page tracking and entire snapshotting. And once that's done, we can then look at these other issues around what's going on with large parameters and why do we need to take so many copies in order to move some data from the host to the guest, and do we even need to move it? Maybe we can just map it. Anyway, questions, anyone? I won't stop sharing just in case someone wants to ask questions about the numbers and just spotted something that I haven't.
I have a question.
Yeah.
So I assume with your changes, you're still taking a initial snapshot of the entire memory when you create the multi-use sandbox. Do you do that?
No.
Then how do you know what to restore the dirty memory to?
So basically, there's two things. One, the way that memory is tracked in the host is by making the pages read-only in the host and then trapping the zigzag violation and then basically recording the page number and making the page writable.
I see.
And I suppose that relies on the fact that the memory in the host doesn't change the memory once the sandbox has been launched. At least that's the way things are today. So once we've initialized, we don't ever change the memory in the host again. So we only have to track dirty pages in the guest from that point onwards.
I see.
And by the way, I used a proportion of the code that you'd written previously for merging and unioning bitmaps.
Oh, nice.
Any other questions?
There's a question from Lucy in the chat.
Oh. Where do I get to the chat now?
Do you want me to read it out loud?
Yeah, please.
Yeah. I assume what you have here is dirtying only a small percentage of the heap. Do you have a sense whether the amount you are using is realistic for regular workloads?
Oh, that's a good question. I have no idea, no. But that's correct. And I think that's what this bottom thing shows, where there's a large percentage of the heat getting dirtied in these bottom scenarios, if not all of it. And that's why there's this bottom scenario shows that it's not necessarily always faster to do it the new way. But I don't know what we should do about that, whether we should have a switch, whether we should try and build some heuristic that works out whether to do a full snapshot or a diff snapshot. I do think that this presents us with the potential to do initialization offline quite nicely, and we can probably cut down sandbox create. Well, we might be able to cut down sandbox create time by doing the initialization offline and just loading the memory at runtime. That would be an interesting experiment to do. Maybe that becomes good enough. I don't know. I think there's lots of testing and observation we have to do with this.
And there's another another question from Lucy as well. We might want to compare with copy on write and write the snapshot into an MFD and then mmap map private or something similar.
Yeah, I think there are some opportunities to do that in some places as well. But that means, I think, in many cases, if not all, copy on write in the guest. So yeah, I don't think there's one solution to the problems that we have, and it doesn't look like there's a one size fits all solution either. So I agree.
We have a little over 3 minutes too, just a warning. I think I'm less favorable on the heuristics-based approach. I think that's going to be really hard to actually get right. So maybe let's switch at first, then we can just do profiling, especially with the benchmarks we showed.
Yeah, okay. Sounds good. James?
So does it seem like the dirty page tracking might help with the WASM scenario? Or
I think so. But it depends on how much of the size that WASM needs is read-only versus read-write, I guess, ultimately. But I think we should try it, and I think it might. I think it comes down to what Lucy asked, which is how to, in a typical usage pattern, which we don't know, which one's best. But I do think if we solve this bottom scenario with all these copies that are being made, it'll have an impact both on this and on overall performance without this. So that's possibly where we should focus our energy in the short term.
I think in the case of Hyperlight WASM, it's likely this is the case, especially because a lot of the space we're using it for storing the binary of the runtime and the binary of the WebAssembly file that we want to run.
Yeah, but I also think that probably the Hyperlight WASM scenario will also suffer, at least on initialization, from this, where the parameter is quite large, so we need a massive heap. And if we're modifying it, then it may end up modifying.
That's where maybe the changes from Dan to introduce the blob may help.
Yeah, that's probably true, because it won't do all the heap allocations in that case.
1 minute, too.
Okay, I'm done. I'm just answering the question.
All right, I don't think we're going to get the issue wrangling today. Any closing remarks for the last 20 seconds? All right, if I could sum this up, we have a lot of performance investigations to do, and this is going to be a lot of fun. So If anybody's interested out there, please jump into the Slack channel. Come visit us. Let's work together and build some cool stuff. All right. Really appreciate everybody's hard work and looking forward to seeing some really cool stuff.